For today, the topic of discussion is phase changes in matter and how kinetic theory of matter is related to them.
We have already learned the four assumptions of matter, and it's all matter is made of particles. Particles of matter are consistent in motion. The higher the temperature, the faster the particles are going to move, and the faster they move, the more space they take up.
So we already know that things can melt, freeze, and boil. For example, everyone knows about ice, water, and steam.
So then what we're learning today is the new thing to understand is what makes things go from one phase to another. That is, why do things melt to freeze?
This will be examined from the perspective of the kinetic theory of matter. There we go.
Okay, the flame is adding energy to the flask, and the molecules are moving faster, so the temperature is going up.
However, once the temperature reaches 0 degrees Celsius, something will change. Instead of the molecules speeding up, the energy will break the attractive bonds that give the solid its shape.
But as the temperature will always stay the same as the solid becomes liquid.
This is a vital key concept in understanding phase changes. Instead of raising the temperature, the energy that enters the solid breaks the bonds that hold solid in a definite shape.
The molecules are still attracted to each other, but not strong enough to have it be a fixed shape.
Once all the bonds between the molecules of every solid are broken up, then everything's a liquid. And at that point, the energy will once more begin making the molecules speed up, and the temperature will start going up.
The same thing will happen when the temperature reaches, for water that's 100 degrees Celsius. At the point, the energy will start overcoming attractive forces and give liquids a definite volume. Molecules are going to break from the liquid to the gas state and leave the liquid to rise into the air.
Again, instead of the temperature, the energy will break the bonds into a liquid to hold a constant volume.
Okay, so melting is when it goes from a solid to a liquid. Freezing is when it goes to a liquid to a solid. Vaporization is when it goes from a liquid to a gas. And then condensation is when it goes from a gas to a liquid. And then sublimation is a process of when it's going from a solid to a gas. And then deposition is when it goes from a gas to a solid. Ionization is when it goes from a gas to a plasma. And then recombination or deionization, the process of changing plasma to gas.
So what's on the Bunsen burner is ice, and that's melting. It's changing from a solid to a liquid. And then the reverse of it is freezing, which it was the ice. It turned from a liquid to a solid.
Does anyone have any questions up to this point?
Once the liquid is boiling, all the energy from the flame goes into breaking the bonds rather than raising the temperature.
The temperature will stay at 100 Celsius until the liquid phase changes into a gas.
Have you ever built a snowman?
Yeah.
And remember two winters ago, it never got above freezing for like the whole winter?
Yeah.
Did you build a snowman and he started shrinking?
Yes.
Yeah.
So what happened if it never got above freezing? Why did the snowman get smaller?
Because it got warmer. It was warm. It wasn't cold enough to sustain itself.
It was below freezing though. It was like 10 below, and the snowman's still disappearing.
What's the direct sunlight, whatever?
The direct sunlight caused sublimation. So when Frosty the Snowman disappears, that's sublimation. Okay. So on the sunny day, the snowman, it's 10 below zero, yet the snowman keeps getting smaller and smaller. The molecules are going directly from a solid to a gas. Deposition is the process of changing from a gas directly to a solid. And you've all seen this. Anybody been to A&W? The A&W root beer place? You got the frosty mug?
Oh, yeah.
So they bring you the mug and it's all covered with frost, or you go out on a cold morning and your windshield is covered with frost. Yeah. There was never a water phase. It goes from gas directly to frost. So Frosty the Snowman disappearing, sublimation. Frost on your windshield is deposition. Okay, so those are two examples that you've all experienced, or many of you have experienced, but yet we sometimes don't exactly know what to call them.
The same thing will happen when the temperature reaches its boiling point. it's at 100 Celsius. At that point, the energy will start overcoming the attractive forces that give liquids a definite volume. Molecules are going to break from the liquid to the gas state and will leave liquid to rise in the air.
Again, instead of raising the temperature, the energy will break the bonds and hold liquid to a constant value. Once the liquid is boiling, all the energy from the flame goes into breaking the bonds rather than raising the temperature.
Temperature will stay at 100 Celsius until the liquid is phase changed into a gas.
So now that it's boiling, we're going to put on stop. Careful. Now the steam is passing through the tube. The gas molecules are 100 degrees Celsius, but they're passing through the tube that is at room temperature, which is about 20 degrees Celsius. So the cool tube will take the energy out of the steam and will phase change back to water, then cool more. A gas turning into a liquid is condensation.
The phase change takes energy out of the gas and it goes from the gas and it goes through the tube. With the energy taken out, the molecules of the gas are caught by the attractive forces and they become once more a liquid. So here we have demonstrating the three phase changes: melting, boiling, and condensation. Okay, so then the endothermic changes or the exothermic changes. The exothermic is a process that absorbs energy, so it's giving it in, and then exothermic is giving off energy, so energy exits from the system. And then
So
Riley,
certain phase changes that can be endothermic is melting, evaporation, sublimation, and ionization. And then exothermic is freezing, condensation, deposition, and recombination and deionization.
All right, so they're going to demonstrate another of the terms.
There's a cut on my hand.
For a liquid becoming a gas. So now they're going to demonstrate evaporation. So evaporation is down in the notes further down on the screen now. So explain what you're doing.
I just poured alcohol onto his hand, and then it's gonna evaporate.
So what do you feel?
Move in. Oh, all right. Feels kind of cool.
Okay. Is it boiling?
No.
Is it going away?
So yeah, it's going away.
And that is
Evaporation.
explain evaporation. So the definition of evaporation is
Is a process that changes the substance from a liquid to a gas at the boiling point.
below the boiling point.
Below the boiling point.
Okay. So how is evaporation different from vaporization?
Evaporation is it going into the air below the boiling point. Vaporization is it actually boiling. The main point of today's discussion was to understand how phase changes happen. When the energy is being added to the substance, most of the time, the energy will make up the molecules speed up.
However, at certain points, instead of raising the temperature energy, it will break the bonds and hold the substance together.
At the melting point, the energy going into breaks the bonds that give solids their definite shape.
At the boiling point, the energy is going to break the bonds and give liquids their definite volume.
And the opposite is true for condensation and freezing. The molecules give off their energy and become bound to each other by forcing the tracks particles to each other.
Don't clap.
Don't clap. Don't clap.
You gotta get a 2 out of 5.
Was I helpful sitting here?
I think you guys nailed it. Third try, last try. Here we go.